If you are starting to feel the afternoon slump kick in, right? But don't worry, we are about to take a journey across Europe, again, not by flights or by train, by through Python code. So during this journey, we'll be visiting different countries like Germany, France, Italy, and many more. Instead of worrying about the visa stamps, we loop through the data using the population, Euro population, GDP, and also little chaos in that. Along the way, we'll also meet a most underrated yet powerful tool called itertools, a part of a Python standard library, which is slightly and very important for writing faster and more memory efficient code. So let's see how it is. So why itertools actually matter first? So if you see the image, most of us being the left side person, right, where we try to code, where we are trying to write the code that loads everything into the memory. And it works well, but unless it doesn't, like, for instance, suddenly your RAM is just on fire and your laptop fan sounds like a jet engine, and sometimes your data pipeline also give up. But Python helps us to calm, in an efficient way, the person which you are seeing on the right? That's where the itertools actually come into the picture. And this is one of the little weirdest, sad, important slide in one of my presentation, the European data crisis. So I was analyzing the European data for different countries. And at first, my Python script started processing, and it was going well. But again, after some time, it got crashed and ended up with memory error. Does that sound familiar to you? How many folks here in this room has seen this error called memory error while they were working? Of course, mine, right? If you haven't seen the memory error, I think then you're not a Python dev, definitely. Again, I'm just kidding, but at some point of time, you'll see the memory error in your life. Right, so what I was trying to do is, so when we end up with memory error, so how should we deal with this, right? So it's not because the problem of the computer, like it's not about the RAM always, it's all about how you write your code. These sort of crashes usually happens, right, when your code trying to create a huge list in the memory, like millions of combinations at once, right? And this is where we need to figure out how we are going to solve this problem, right? So in order to handle these sort of problems, this is where the itertools, a Python standard library, comes into the picture, and it has a pretty much standard way of handling these problems. So we'll see how we do that. And so when I was talking about the data problem, right, the European data problem, and here is one of the small chunk out of my huge data set. I picked up the small chunk and I put it in the slide because it was very difficult to put me the whole bunch of code or whole bunch of information in one slide, right? So if you see here, so we have a three list here, like we have a European countries information, we have a population, we have a GDP data, right? And what we are trying to do is, we are trying to use the nested loop. We are trying to use this nested loop and trying to combine them, like countries with populations with GDP, and trying to store it in a combined list. Okay? And at a glance, there is nothing wrong in the code that you're seeing on the slide, right? to be honest, there is no wrong at all in that. But imagine, as I mentioned, when this is like a small chunk of information, but assume if you are dealing with 10 different countries and each of other list has 1,000 entries. Now, if you do the mathematics, right, 10 into 1,000 into 1,000, which is like, 10,000 million entries of a data that is being getting stored in a huge, in your memory, right? And if you look at the command, one of the command, which is called combine.append, because combine is the list where we are trying to store the data, and the combine.append, now this command will be a monster here. What happens? It tries to store all these 10 million entries into a memory. That's like, huge, right? So for the 3 list information, like, for sample data, it's consuming 290.45 MB. Now, imagine if we are trying to do this for 10,000 million entries, how much memory it would take it. I leave it to your imagination, right? Right. So to be honest, this process can pretty much good if you are trying to deal with a small data sets. But in real life situations, we often see like, the process logs, stream files, and also the parsing CSV, like, big CSV files, right? So that cannot be scaled with this approach. And the worst part is you don't even notice until it crashes. Right? We don't even know. We just simply write our own sort of a logic code, but until it get crashed, then we realized, okay, this is what it happened, right? So the question is, how do we do the same thing, looping through all the data, but without burning the memory? This is where our, the superhero comes into the picture, and it has a way to handle these things in a very smart way. And some of the key benefits that you need to understand about itertools is memory efficient. Because as I mentioned, so it processes the data one at a time. So there is no point of, it doesn't go and create a huge giant list of information in your memory. And the second one is fast performance, because it's pretty much implemented in C Python. So if you write like, very memory optimized code, it will execute like this. You don't need to worry about the time and memory with the itertools. And the third best thing is it's part of a standard Python library. So you don't need to go and do the pip installs, or you don't need to do anything. It's just simply import and start working on it. And finally, one of the very important point of itertools is it scales pretty much to the massive data set. So if it is a streaming logs or big CSV files, or even if you have a huge data sets, it works pretty well with the itertools. Okay, so, all right, now we know what itertools is and why this is powerful, right? So, as I mentioned earlier, so we are not just visiting the different places of Europe again, right? So we'll also make stops at different functions. So what we are going to see now is we are trying to deep dive into itertools. So we'll see some of the important functions. And each of these functions has a different flavors and which solves a different sort of a problem that you can add it to your coding list. Right? So just grab your digital passport. So we are about to, go across Europe, and trust me, no memory overload this time, I promise, until the end of the presentation. Okay. Yeah. So firstly, we landed at Germany, which is really famous for doing a smart engineering, right? So here we met the itertools chain function. So how many of you know about the chain function here? Right? Yeah, cool. So basically, chain function is a function. It takes a set of iterables and returns one iterable as an output. So for instance, so it takes all of the list of a combination of your data and and generate one output at a time, right? So if you're seeing the example on the slide, right? So again, we have a 3 lists here, again, list of countries, and we are trying to use the plus operator to combine them. So when you use the plus operator to combine them, right, so this will create a new list in your memory. But if you try to do this by leveraging the chain approach, right, so chain will also loop over all this list information, but it does not create any new list in the memory. It just streams the data as we need. So the important thing here is, so it's not, firstly, it's not creating any list, and secondly, it's not wasting any memory because we are getting one output at a time, right? So which is really clean and efficient way, right? And if you also look at this visually, right, on the performance, if you seriously talk about the performance, right, so chain is slightly faster because, as I mentioned, it does not waste creating a new list. Secondary, the memory is very one big thing because it uses, the plus operator uses a lot of memory, and it tries to build a fresh combined list in the RAM where chain doesn't, right? So with one small change in how you write the loop, right, so we are getting a better speed and using less memory. And this kind of an upgrade that Python itertools gives you out of box, again, no library and no pretty much hack here. It's just simple and straightforward, just one line where you're tweaking the code, right? That's the beauty here. Now, from Germany, we are traveling to France now, okay? And here, we are trying to slice the data elegantly using the slice function. The slice function is try to iterate over some part of the data set from some part of information from your data set. So again, here we have a European budget data. Again, so it has 1 million entries here. So what we are trying to do is, out of this 1 million entries, we are trying to fetch 10 entries. And if you look at the traditional approach process, right, with the list where we are trying to slice it from 1 million to 110 million, right? So to fetch the 10 million entries, what we are trying to do is we are trying to dump the entire 10 million entries into the memory, right? Which is really waste. It doesn't make any sense if you're trying to load the whole data set for a small portion of an operation that you want to perform, right? And if you look at the alternative approach, which I'm showcasing with the slice function, right? What it's trying to do is, this is exactly trying to get you what you're trying to fetch. Like, just getting the 10 entries without not creating any separate list in the memory. And both are trying to perform the same sort of a operation, but this is pretty much, efficient and, optimizing the memory in a better way. And if you also seriously talk on the performance side, you can see that the itertool slice is pretty much good in terms of time execution, in terms of a memory optimization, rather than the native traditional approach, right? Now, if you imagine if you're dealing with million of entries data, imagine how much memory and time you're trying to burn, right? If you're trying to do with the same traditional approach. Now, we have slowly started from, France to Italy, okay? And we are trying to perform we are seeing the repetitive operation with style using the cycle operation. The cycle operation is basically try to iterate over the iterables infinitely until it tries to breaks. So meaning that it does not create any sort of a separate structure, but it loops through over the entire your data. And most importantly, right, and this is especially useful if you are trying to perform the repetitive operations over the data and if you want to start everything from the beginning. And if you look at the code, and most of the code that you're seeing on the slide is pretty much straightforward. I think you can figure it out. Just in case if you're not able to understand, I can give you the full code. You can just play around it at the end of the presentation, right? So the traditional way of doing this is what we are trying to do is it's trying to index tracking, some kind of index tracking, it has been involved. But the problem here is we have to manage that index and also the modular logic manually. But if you try to do the same process with the itertools cycle, so it simply loops over the things completely infinitely. You don't need to calculate any indices or wrap around it. So cycle just keep repeating the process until we want to stop. Here, I put a break at a 24 so that it gets stops. Otherwise, the loop keep on going until we stop, right? So the beauty here about the cycle is it handles the repetition in a clean and elegant way with a zero index tracking. So that's a more power about the cycle function that you're seeing. And if I also talk about the performance-wise, right? So you can see that how effectively it is optimizing the memory, right? Though it's trying to do the repetitive process multiple times. But again, this is a small chunk where you're seeing the memory is a little less. But if you're trying to handle very big data set where it might consume more memory, but in terms of execution, right, it will be very fast. And now that we are in Spain and we are trying to count the count of iterables using the count function. So it basically tries to count the infinite numbers, and it's really useful if your infinite numbers are needed and without storing them. That's really important. So if you look at the example, we are trying to generate the citizen IDs, right, from the number 100K, and where you are trying to increasing by 10 with a 10 number increment. So the traditional process looks pretty much same with a with a list of a range function. It's cool, but the problem is the whole 100K IDs are sitting into your memory, and that's huge chunk of a memory that you are trying to consume. But by leveraging the count function, what you are trying to do, you can generate the values in the flight, one at a time. And this is one of the perfect example for the lazy evaluation. So so there is no list that is being created in the memory. It's infinite by design, but fully under control. And so this is trying to give what you actually need, nothing more or nothing less, just on point you're trying to perform, right? Whatever you want to get, you are trying to get it, nothing more or nothing less, right? On a performance side also, right, so you can see the time and memory usage are pretty much less than the native range function, right? So that's the main crux about this function. And finally, not finally, so we are in Netherlands again, which is pretty much known for neat, organized, and structured, right? So this is a perfect match for group by function in itertools. So what this group by function does is, I think you all pretty much know, so it tries to group the consecutive elements in iterables based on the key function. And again, it's similar to the SQL group by, but the only difference is it works based on the sorted iterables. So what does that? I mean that is we have here the European trade data across different countries, regions, everything. So what we are trying to do is we are trying to group this country's information based on their GDP tiers. So if you look at the code, right? So in order to perform the group by, we first need to sort the data based on this group by key, right? So then only you can perform the group by. So once you sort the data, then you can perform the group by operations, and that is pretty much giving you the data based on your GDP tiers. And most important point that you should remember here is group by does not work magically. So you first need to sort the data based on the group by key, then only you're able to get the results, right? So that's the main difference here. And on a performance side also, so the manual grouping is usually faster because it's just a one process that we are trying to do it. Here, when it comes to itertools group by, the problem is what you're trying to do is you're first trying to sort the data and then you're trying to perform the group by operations. That's the reason why it's slightly slow, but again, but overall it's very elegant if you think about readability and in writing in an efficient way of code. Yeah. And next, we are at the Belgium. Again, one of my favorite places because it's pretty much it's pretty famous for chocolates and its strategy of mixing things well, right? So So here we are trying to look at the product function, right? So this function try to create a Cartesian product for the input variables. So if you see here, we have a different European trade data, like across regions, across trade types, and commodities. So if we want to understand or explore the combinations, right, different combinations between the data, for example, let's say whether the South European region is exporting tech or North European region is importing food, right? If you want to understand those sort of a combination, right? So the product function will pretty much create this. So yeah, right. So this goes through the all possible from those lists, the trio list that you are seeing on the screen, and it gives us a combination of like 2 into 2 into 3 because it's a 2, 2, 2, 3, right? It's a list, right? So and you see the 12 combinations one at a time. And if you see here, there is a no nested loop, no complicated logic, right? Just like Belgium chocolate, right? Every combo is neatly prepared and pretty much delivered, right? It's very straightforward, right? And on a performance side, right, the memory consumption of a product function is much more efficient, if you see, though it's a little time-consuming compared to the native process, but it's not taking huge memory, which is really important. And we are at Switzerland now. So again, as I heard, it's a country for good for precision clockwork organization and attention to every possible order, right? So again, here we are trying to do the permutations. Again, the permutation is pretty much similar to the product function where we are trying to explore the different combinations, but permutation handles the data combinations only from one set of input variables here. So if you see in our example, so we have European ministers' information where we want to figure out all possible ways that could they meet, in what order the meetings could happen, right? So we are trying to look at those combinations, right? So now if you look at the output, the output has pretty much give us the 6 possible arrangements of these 3 ministers. Again, if you see, I didn't have any, there is no nested loop, again, no index juggling, just run one line of a code that gives you the precise order results. And this is ideal, especially if you need to explore like, sensitive combinations, and it does it like, Swiss-like clarity. That's it. And on a performance side also, if you see that it's pretty much faster, and the memory consumption is also very less comparatively with the native approach that you're trying to do, right? And finally, our last stop is Austria, and country known for classical music, harmony, and beautiful paintings, right? So this makes it a perfect match for itertools combination, right? Again, the combination is also pretty much similar to the permutations. It tried to find all the combinations from one set of input. The only difference is we can set the output length using the combination function which you can see on the code, right? So again, here we have the European committee for 4 countries. We want to form a special 2-member subcommittees from the code, right? So, but we don't care about the order here, like Australia and Germany is same as Germany and Austria, right? So we doesn't care about that. So with the combination function, so this try to give you all the unique pairs from the list, right? So so again, order doesn't matter. No repeats at all. You see all the unique entries that has been provided by the output. So again, this is a perfect when you want to do the possible groupings or matchups done in a clean and more readable way. And if I also talk about the performance-wise, right? So it's again similar to the permutation, much more efficient in terms of speed and memory, and yeah. And most importantly, so one of the takeaways that you should think about when to not use itertools. If it is a very small data set, definitely you should not use it because tomorrow, if someone comes and asks me that, as per your presentation, you say that itertools works very well, but when I tried with small data set, it was not working. It will not work with small data set. And if you're trying to perform one line of operations, definitely itertools is not a right choice. And yeah, code readability is more important than performance. So if you you're really concerned about the readability access, again, sometimes some sort of a logics people might not understand. So it's better you think about it whether you are trying when you're trying to implement the tools in your your real workflows. And lastly, if your team is not familiar with the itertools, don't try to write the code, because if you are trying to collaborate the project in a group environment, if someone is not able to understand the logic behind the code, then it will be a big problem for you, right, while you're writing. And thank you for joining the European journey through Python optimization with me. And I'm sure if we run out of time, no worries, let's catch up with the coffee and continue the conversation. If you have any questions, feedback, or concerns, whatever you have for me, feel free to come and talk to me. Yeah, if you want to connect with me, these are my social handles. Yeah, that's pretty much I have. Thank you so much.
Actually, we have plenty of questions. Sorry. Plenty of time, 5 minutes actually, 4 minutes. So if anybody wants to stay here before the coffee break and ask some questions, then please.
Hello.
Hi.
I have one maybe slightly stupid question, but what happens if you apply itertools to an iterator that changes the state? So for example, with the iSlice, where we only take intermediate values, does it work, or what happens?
Sorry, I'm not able to catch your question. Can you
If you apply itertools, for example, the iSlice operator, it only took intermediate steps. But what do you do if you apply itertools to an iterator that changes the state when you iterate over it? What happens? Because you only take the intermediate ones, and you would kind of miss the first. Does it have to calculate everything beforehand as well, or?
Yeah. So basically, when you are trying to iterate through with slice function, so basically you should think about, for example, at what number you are trying to perform the operation. Do you need to set certain sort of a indexing for that? Otherwise, it will be big problem for you. Was it the same question? Okay. Did I answer, or maybe we can?
I didn't answer acoustically, but now I did so.
Okay, got it.
Yes, please.
So I was a bit surprised by the performance of iSlice. And so I just tested on my laptop. And so the expensive part of that, I think, was more creating a list out of the objects. So iterating over a slice of an object which already supports slices is way faster than using iSlice. But of course, converting something that isn't yet sliceable is very expensive.
Yeah, so when you try to do the native approach of slicing, I think because that's where you are trying to create a separate object into the memory. So definitely there will be huge memory consumption, and again in terms of execution also, because you have already loaded the data, right? So the performance can definitely dip. But if you do it with a slice, I believe that the memory and time are pretty much efficient. I mean, all these are based on my experimentation that I have done on the dataset. But yeah, that's what I feel. Yeah.
Thank you.
Yeah.
One last question. No, well, I asked one. I mean,
Yeah.
you showed some examples but can you share with us maybe a project where I would say a real world project where using itertools actually improve the performance?
So I pretty much work in the data space, right? So whenever we try to handle with huge data sets, right? When we are trying to do the data analysis with the huge data sets, so wherever it's required, I try to leverage the itertools and try to write the code in a more memory efficient way, so that it will not burn my memory, and also parallel it will not run my issues with my computer. So that's what I do. Yeah.
Okay. So let's thank Kalyan one more time, please.